Now let's see if there's any constraints that we can use to simplify our problem. Let's look at the conditions provided by the problem statement. It says that the friction between the two blocks is keeping the top block from sliding off the bottom block. This means that these two blocks must move with each other, and therefore they will have the same acceleration in the x direction. This gives us a condition that the acceleration of block 1 will always equal to the acceleration of block 2. Now, because the rope has negligible mass, it means that the block will always tighten the rope such that the rope is always forming a straight line. So we know that the blocks over here will move the same distance as the distance that block 3 dropped downward. So we know the acceleration of n3 must also be related to the acceleration of these two blocks. And because n3 is moving in the y direction, we relate the y component of acceleration with the x component of the acceleration. But because we set the y component to be positive upward, so when we have a downward moving direction, we need to add a negative sign. So the acceleration of y component of block 3 will have a negative value, which gives us a positive x direction of these two blocks. And because the rope has negligible mass and the pulley has a negligible friction, it means that the pulley will always give a normal force that is making a 45-degree angle over here. Now, because the mass of the string is 0, if we write out Newton's second law on this string and the mass is almost 0, it means that the force acting on the string must also be 0. Otherwise, the acceleration will grow to infinity, and that's not going to happen in real life. It means that the only result is that when m is close to 0, both F and A are 0. So it means that the tension on the side of the rope, which is connected to block 2, and the tension on the side of the rope, which is connected to block 3, must equal to the component of the normal force here. T3 need to equal to T3 so that in the y direction, the net force acting on this rope is 0. For the x direction, T2 must equal to the x component of this normal force. And because this normal force is making a 45-degree angle, these two components should be the same. Therefore, we can get that T2 and T3 must equal to each other in order for the mass of the rope to be negligible. In our previous notation, it means that the tension force acting on M2 and the tension force acting on M3 should equal to each other. So these are all the constraints that the problem statement gives us. Let's copy them and put it downward here. Now we can use these constraints to simplify our calculations by using a same variable to rename them. Let's name all these accelerations with acceleration A and the tension by capital T. Make sure to be careful when we use AY to rewrite it. When we write AY with A, it's going to be minus A because there's a negative sign here.